Good morning, students. Today we will discuss about the stack, and stack is important topic of the microprocessor. So, stack is nothing. It is an area of memory identified the programmer for temporary storage of information. प्रोग्रामर टेम्परेरी स्टोरेज इन्फॉर्मेशन के लिए एक मेमोरी रैम का एक पार्ट को रिजर्व कर लिया जाता है. उस रिजर्व पार्ट रैम को क्या बोलते हैं? स्टैक. सो स्टैक इज नथिंग, इट इज़ अ रिजर्व पार्ट ऑफ रैम. सो रैम का ही पार्ट है, बट इट इज़ एक्सेस डिफरेंट फ्रॉम द रैम. एलिमेंट्स कैन बी एक्सेस फ्रॉम द रैम in random order, or any element from the RAM can be accessed at a time randomly. But in stack, no element can be accessed randomly, because the stack operates on the principle of LIFO, last in first out structure. Means the value which is entered first can be read out at the last, and the value which is entered last can be read out from the first. So stack operates on the principle of LIFO. It is the important. LIFO means last in first out. जो वैल्यू लास्ट में आप एंटर करोगे, स्टैक में रखोगे, वो वैल्यू आप पहले बाहर आएगी. सो स्टैक नॉर्मली, अगेन important part of the stack normally grows backward into the memory. Stack grows backward means the elements can be entered. When we entered the element into the stack, the memory address will be decremented. Memory element can be decremented means from top address to the lower address. The stack will be operated from top memory address to the lower memory address. So this is the stack. Stack is also one definition of the stack is the memory location in read-write memory RAM, which is used for temporary storage of binary information during the execution of the program. It is implemented in the last in first out manner. That means the data written first can be accessed last. So stack can be used by the programmer as well as the processor also. So for an interrupt, for example, interrupt, during the interrupt, microprocessor use the stack to save the contents of the registers, address of the next memory locations, etc. So both processor and control programmer can be use the stack. So stack can be accessed by using the pointer SS and SP, where SS the stack segment and SP the stack pointer register. As we know that to access the memory, we have to require 20 bits physical address in 8086 microprocessor, and its 20 bit physical address will consist of two parts: base address plus offset address. So base address of the stack will be provided by the SS. SS provide the base address of the stack, whereas the offset address provided by the stack pointer register. So base address will always remains constant, where the contents of the stack pointer will be changed. So stack can be accessed by using the pointer SS and SP. So one can put the data on the top of the stack by a special operation known as the push. So stack can be used to read the data or to write the data. So whenever we have to write the data on the top of the stack, we use the instruction push. Push instruction is used to write the data on the top of the stack. What do we mean of the top of the stack? Top of the stack means when we write something on the stack will be filled. So up to which position the stack is filled, at that address is known as the top of the stack. Again, up to which position the stack will be filled is known as the top of the stack. So whenever we have to write the data or read the data, the contents of the top of the stack will be incremented or decremented. So to write the data on the stack, we use the push instruction, whereas to read the data from the stack, we can use the pop instruction. So pop and push instruction are used to write the data on the stack and to read the data from the stack. And special purpose register, special register that is known as stack pointer register, points the top of the stack. But again, up to which position the stack is filled, that address will be pointed by the stack pointer register. Next, so put pop options. How these push and pop options are executed when we have to write the data. So we have to use the push operation. So in push operation, first the contents of the stack pointer will be decremented. First, the contents of the stack pointer will be decremented, then write operation will be performed. ठीक है. Again, when we have to write the pop operation, in pop operation, first the read operation will be performed, and the contents of the stack pointer will be incremented. So in push operation, write operation will be performed, but before write operation, the contents of stack pointer will be decremented. It should be noted. And pop read operation is performed, but before read operation will be performed later. Read operation is performed the first, then the contents of stack pointer will be incremented. Right. So in you can see here. So we have to push. For example, we have to push AX, where the AX contains the information. AX contains the information is this. AX contains 1, 2, 3, 4 H. The AX data is 1, 2, 3, 4 H. So we have to push the data on the stack. So this is the before condition, before the push instruction. Push instruction concern, this is the stack. You can see this is the stack. So these are the memory address. First 1000 shows the, here 1000 shows the stack segment and 2000 shows the stack pointer. 1000 is the contents of stack segment and 2000 is the contents of stack pointer. Stack segment हमेशा फिक्स होती है वैल्यू, स्टैक पॉइंटर की वैल्यू चेंज होती रहेगी. ठीक है. सो दी आर द स्टैक इन विच एनी इन्फॉर्मेशन देयर इज नथिंग. सपोज देयर इज नथिंग, है ना. स्टैक इज एम्प्टी. स्टैक इज एम्प्टी. सो बिफोर द पुश ए एक्स, अभी पुश ए एक्स को एग्जीक्यूट नहीं किया है. टॉप ऑफ द स्टैक इज दिस. दिस इज द टॉप ऑफ द स्टैक. राइट. एसपी ऑलवेज, जैसे हम बता चुके हैं, स्टैक पॉइंटर ऑलवेज shows the top of the stack. So this is the top of the stacks. So this is the before push instruction. Now we have given the push instruction. पुश इंस्ट्रक्शन दे दिया. सो व्हाट हैपेंस, हमने बताया था पुश में होता क्या है. फर्स्ट द कंटेंट्स ऑफ स्टैक पॉइंटर विल डिक्रीमेंटेड. सो द स्टैक पॉइंटर कंटेंट्स इज 2000H. वी कैन से द स्टैक पॉइंटर कंटेंट्स इज 2000H, and when it will decrement it, 2000 minus 1, 2000 minus 1. So when it is decremented, जब आप 2000 में से 1 को डिक्रीमेंट करेंगे, so the address becomes 1 FFFH. So first the decremented. So when we decremented, the stack pointer will be shows this. Now at this memory location, the data will be right. So this is the higher memory location. So data of AH register will be transferred here. AH register will be transferred. This is the AX register, which is the, this is AL and this is H. So AL contents register will be transferred. Again decremented. The stack pointer will again decremented. So 1 FFFH is decremented. The stack pointer becomes 1 FFFE. Again the contents of, now the contents of AL will be right on the stack. ठीक है. So after the write of the stack, 12 will be here, 34 will be there. Then now the stack pointer, this is the stack pointer. This will be the top of the stack. अब टॉप ऑफ द स्टैक यहाँ हो गया, क्योंकि यहाँ तक हमारा स्टैक क्या हो गया है, फुल हो गया है. सो दिस विल बी द टॉप ऑफ द स्टैक. So in this way, first the stack pointer will be decremented, then write operation. Again the stack pointer will be decremented, then write operation. So this is the push operation. And pop operation, में क्या होता है? First the contents of the stack pointer will be read. The contents of the stack pointer will be read from the top of the stack. Then the stack pointer will be incremented by 1. So suppose this is the stack, this is the stack and this is the top of the stack. यहाँ तक stack हमारा fill है, यहाँ तक data है, so this will be the top of the stack. This address contains the top of the stack. So before pop, the stack pointer is 1FFFVH. This is the top of the stack. ठीक है, before pop instructions. ठीक है. Now after pop, first the read operation will be performed. So we have given instruction pop x. पॉप एक्स दिया मतलब ए एक्स में डाटा रीड होगा, स्टैक का डाटा कहाँ ट्रांसफर होगा? ए एक्स में. सो फर्स्ट जो भी स्टैक टॉप ऑफ द स्टैक होगा, टॉप ऑफ द स्टैक, ये दिस विल बी द टॉप ऑफ द स्टैक. सो कंटेंट्स ऑफ दिस मेमोरी लोकेशन विल बी द ए एच रजिस्टर. नाउ अगेन इट विल इंक्रीमेंटेड. सो 1FFV में आप इंक्रीमेंट करोगे, सो द मेमोरी लोकेशन विल बी 1FFH एंड द कंटेंट्स ऑफ दिस मेमोरी लोकेशन विल बी ट्रांसफर्ड टू द ए एच. And again it will be incremented. So increment okay. Now the stack pointer will be 2H. So this will be the pop operation. So push operation में first it will be decremented, then the write operation is performed. Whereas in pop operation, first it will be read operation is performed, then it will be incremented, the stack pointer. So this is the function of stack pointer. If you have any problem, you can call me, you can contact me. Okay, thanks.